Good morning. Welcome back. So, last class we started with deletion of a node and we did deletion of the first node in the list, that is the node to which head is pointing to. So, in today's class we will be starting with the deletion of the last node in the linked list. Which is the last node here? You can see that in a single linked list the first node is identified by the pointer head, like head is a pointer which would be pointing to the first node in the list. So by that we can identify which is the first node, and the last node is identified by its link part, that is in a single linked list. The last node's link part would be pointing to null. That is how we identify the last node in the list, and each node will have the information, or it would be pointing to the next node. So you can traverse in only one direction and it is scattered throughout the memory, because we don't create all the nodes at the same time, like because during compilation time if I create, then it would be a block of memory. Since we are not doing it during compilation time, it is during runtime we are allocating dynamically memory. So I need to, it won't be in the same one next to another. It is not contiguous memory spaces, it is scattered throughout the memory, and then you have, each node would have the information about the next node in the list, and we can traverse it using the link, like link part of the node would be a pointer which would be pointing to the next node in the list, and using current pointer, I have given name as current pointer. Only thing which is required is it should be a pointer which would be pointing to a structure node. So you need to declare a pointer which of that type, and the name does not matter. You can give whatever name, it's just an identifier name. You need to follow all the rules while you're naming the identifiers, and it's just a name given to the pointer. So I have given it as current pointer, previous pointer, head. You can give whatever, you can give as p1, p2 and start, or first pointer, whatever. You can give whatever name you want. But here the pointer head is used for identifying which is the first node in the list, and it would be pointing to the first node. And then I have two more pointers, that is current pointer and I have previous pointer, because when I am deleting a node, I would see, if I delete this last node, then this should become the last node of the list, right? So I should have a pointer which would be pointing to this, like I need to keep track of the last but one node, because once I delete the last node, then the last but one node should become the last node of the list. For that reason I would need two pointers here, one for the last node and the other for the last but one node, so that once you delete the last node, then because from the last node you cannot go back to the previous node, because last node has no information about the previous node, because I don't have a pointer to the left part, right? I have only the information part, and then I have a link part which points to the next node, not the previous node. So I need to have two pointers, because I need to keep track of the last but one node. After deleting the last node, the last but one node becomes the last node of the list. That is why I have let list let list be a linked list stored in memory. It deletes the last node from the list. I am going to delete the last node from the list, and head gives the address of the first node, and current pointer is a pointer which is being pointing to the current node, and previous pointer is a pointer which points to the previous node of the current node. Like for example, current pointer is pointing to this node, and previous pointer would be pointing to the one behind that, that is the node one before that. Getting it? Like current node would be pointed. Current pointer is a pointer which would point to the current node, and previous pointer is a pointer which would be pointing to one node previous to that. Suppose if current pointer is pointing to node third, that is the information part of the node whose information part is 89, then previous pointer would be pointing to node number 2. Getting it? Then I will write the algorithm and I will explain it to you how exactly the deletion operation works. We'll start with what is the first step when you are deleting something. We need to check whether there is something to delete or not. Because if something it is already empty, there is nothing to delete, then I cannot delete anything. To delete, you need to check whether the list is empty. If the list is empty, it gives rise to a underflow condition. You need to put that message to the user because there are no nodes to delete. At least one node should be there in your list to delete. So whenever deletion operation happens, you need to check whether there are any nodes in the list to delete or not, whether it is giving rise to an underflow condition. Underflow because you don't have anything and you are trying to delete. Overflow is when it overflows. So you cannot name underflow as overflow, because I am telling this yesterday few of the students, why not overflow, why underflow? Because you don't have anything and you are trying to. Overflow is when you have something in excess, there is no place for it, that is overflow. So we will be checking for the underflow condition. I am not checking for overflow because I am creating it dynamically. As long as memory space is available, I can create nodes. And nodes are finite because you don't have infinite memory. Getting it? So step 1. What is step 1? I need to check whether the list is empty or not. How do I do that? If head is null, head is the pointer which points to the first node in the list. If there are no nodes, then head would be null. Only in that condition head would be null. Otherwise head will not be null. Head is null means there are no nodes in my list. That is, my list is empty. Under only those circumstances head would be null. So let me say if. Since this is an algorithm, I will not be using double, single, but when you are writing the program, you need to use the proper operator when you are comparing, because equal to and double equal to, they are different. Assignment and comparison are two different operations. Getting it? Head is equal to null. Then what I have to write? I have to write print or display list empty underflow. Empty okay, and after that you are exiting it. You don't have any work to do. Next, this is the first step, that is checking whether there are any nodes in the list to delete. If yes, if there are no nodes, that is if head is null, if that is true, then you are going to print list empty underflow and you are going to exit. Suppose if there are nodes in the list, that is my list is not empty, I can delete, then since I need to delete the last node, because I am writing this algorithm to delete the last node in my list. To go to the last node, I need to start from the first node. I need to traverse till the last node. Getting it? For that traversal, I would be using a pointer called current pointer. Step 2. So now what I need to do? I need to, for traversal, the first thing is initialize the pointer variable current pointer. So where do I initialize it? I need to initialize it to head because it needs to start from the first node. Then I can do this because both are pointers of the same type. I can directly assign one pointer to another. So both now with this statement, the current pointer and head would be pointing to the same memory location. Traverse the list and take the pointer to the next node. Okay, that is step 3. What do I need to do? I need to traverse the linked list and take the pointer to the next node. How do I do that? While I'm writing it in a loop, because until I reach the last node, the same procedure or process I would be doing, since it's an iterative process, because I'm doing the same thing again and again, I would be writing it in a loop. While length of current pointer is not equal to null. Why is while link of current pointer not equal to null? Because once the current pointer's link becomes null, then I need not do it again, because once it becomes null, it is the last node, right? So do what am I going to do? While it is true, that is the current pointer's link is not null, I will have one more pointer over here, that is in step 4. Prev pointer is equal to current pointer. After that, what am I going to do? I'm going to traverse, right? I will explain this. Current pointer is equal to link of current pointer. Okay, you are going doing this end of while. You write it down, I'll explain it to you. Step 6. Length of prev pointer is equal to null. After that, return the deleted node to the avail list. How do I do that? By using free. Okay. Then step 8 is exit. So this is my algorithm. Hope you have noted down. Now I'll explain you what it is. Fine. I'll explain you with that diagram. Please make a note so that then you don't waste your time writing. I want you to write this. This is more easier than your textbook because I'm not copying whatever is there in the textbook. I'm giving you a easier version or more understandable version of the algorithm than your textbook. See here, the first thing, what am I doing? Checking list is empty. If head is equal to null, then list empty underflow. So is head null here? No, it is pointing to a node, right? It is not null. So this if condition is false, so it will not go inside if and print it. It will skip the if block because only if the condition is true, then only if gets executed. Otherwise, it is skipped. I am writing a simple if here. So simple if I can write it without else, but as you all know, I cannot write an else without an if. You can have an if without an else, and if would get executed only if the condition is true. Otherwise, the entire block is skipped and it will start executing after the if. So initialize the pointer variable. Current pointer is equal to head. So I need to make current pointer is equal to head. Where is head pointing to this location? So I have to make current pointer also point to that location, right? Current pointer is also pointing here. Yes, I am making the current pointer point there because current pointer is equal to head. So current pointer will also point to the location to which head is pointing to. Head is pointing here. So that is why I am making current pointer also point there. Hopefully you have no doubts till now. After that, what am I doing? Traverse the linked list and take the pointer to the next node. While current pointer link is not equal to null. Do. So while condition current pointer link should not be equal to null. This is the current pointer link, right? This is the link of the current pointer. Is it pointing to null? No, it is not pointing to null because you have another node over there. So it will go inside while because the link I need to traverse until the current pointer's link becomes null. Current pointer's link is not null. There is a node after that. So it will go inside while. What happens here in while? I have one more pointer, pref ptr is equal to current ptr. So go back and then where will now pref ptr point to? See, pref ptr is equal to current pointer. So it also should point to the location to which current pointer is pointing to. So where is current pointer pointing to? It is pointing to this node. So definitely pref ptr should also point to that node. That is what I am doing over there, right? So I am making pref ptr also point to current pointer. So current pointer is pointing here, previous pointer is also pointing here, head is also pointing there. All the three pointers are pointing to the first node over here. Getting it? Why am I making that? Also, so after that point, step 5, what am I doing? current pointer is equal to the link of current pointer and end of while. After step 5, again it will go back to the condition header of while loop. If the condition is true, it will go inside the while. So here I am ending the body of the loop. So current pointer is equal to link of current pointer. So what is current pointer's link? Link is pointing to this, yes, the second node, then this node. Link is pointing to this node. So current pointer is equal to link of current pointer. So link of current pointer is pointing here. So current pointer should also point there, right? So make here. By the end of the first iteration of the loop, head is pointing to the first node, pref pointer also is pointing to the first node, current pointer is pointing to the second node. This is the end of the first iteration of the while loop, and these are the positions to which the pointers are pointing to. I hope you have understood that. There is no doubt in this. Now, you can see where is the link of the current pointer pointing to? It is not pointing to null, right? There is a node over here, correct? So again it will go back to the header of the while the link of current pointer is not equal to null. Yes, we established that the link of current pointer was not null after the first iteration of the while. There was a node next, so it will go inside the body of the while loop. What is the first step? 4 and 5 are there in the body of the while loop, right? Pref pointer is equal to current pointer. So where is the current pointer pointing to now? It is pointing here. I'm making pref pointer is also equal to current pointer. So it needs to point to the place to which the current pointer is pointing to, right? I have. So here it will point to this one. Correct? Next, so now after that the step 5, what is the step 5? Current pointer is equal to the link of current pointer. After that, the end of while loop, you need to go to the header of while loop to check whether the link of current pointer is null or not. If it points to null, I will stop executing. Like again, control will not go inside the body of the loop. This is the entry control loop. So you are going to check the condition in the beginning itself. Now current pointer is equal to the link of current pointer. So where is the link of current pointer pointing to? It is pointing to this node. So now current pointer should point there, right? I am doing that. Current pointer is equal to the link of current pointer. So I am making current pointer point here. After that, what I have to do? It will stop there. That was the end of the while. It will go back to the header and it will check whether the link of the current pointer is null or not. If it becomes null, I need to stop executing the while loop. Otherwise, I need to continue executing the loop. That is, the control will go for the next iteration of the loop. Where is this link pointing to? It is pointing to a node, right? There is a node over here. It is pointing. It is not null. So the next iteration of the while gets executed. Fine. What is the next? Current pref PTR is equal to current pointer. So where is the current pointer pointing to? It is pointing to this node. So pref PTR should also point to that node, correct? According to step 4. Now I'll do that. I will make pref PTR also point here. to which place the current pointer is pointing to. After that, we need to do the step 5. Current pointer is equal to the link of current pointer and end of while. Where is the link of current pointer pointing to? It is pointing to this node. Correct? So I will delete this and make the current pointer point to that node. Okay. Now end of while, it will go to the header of the while loop again. That is, link of current pointer is not equal to null. Let us check, but the link of current pointer is null, so it will exit the while. Getting it? When we exit the while loop, the pref pointer is pointing here, the current pointer is pointing here. That is, current pointer is pointing to the last node and pref PTR is pointing to the last but one, that is the previous node of the last node when we exit the while loop. Because the link of current pointer here becomes null, so it will not go for the next iteration. It will work only when the link is not equal to null. Once it becomes null, it exits the while and then you need to execute the lines after the loop. So during, like at the time of exiting from the while loop, the current head is pointing to the first node, pref pointer is pointing to the last but one node and current pointer is pointing to the last node. Then what I have to do? Then after the while, I am making link of pref pointer is equal to null, right? So I have to make this not point here. It should point to null. Getting it? So it is pointing to null. Yeah, the link of pref pointer is pointing to null here. That is what I did over there. After that, what am I doing here? Free current pointer. Free is a function for deallocating memory which was allocated dynamically. What is avail list? Avail list is nothing but availability list of free pool from which you can dynamically allocate memory, and whatever deallocated memory during runtime is put back to the free pool or the availability list so that it can be reused. So I will be freeing current pointer means this gets deleted. Getting it? This node gets deleted using free and then the link is pointing to null. So automatically this becomes the last node in the list because the link part of the last node points to null. Getting it? Hopefully you have understood. Yeah, the algorithm. This is how the deletion works. Now we will write down the function to do that. Please make a note along with me. Function to delete the last node of the linked list. Function to we'll be starting the function now. Please write it out along with me so that you can finish sooner. So let me say int because I'm going to return the integer value whichever is stored. See, here I am saying int because the information part of the node is the int. Whatever is the information part, depending on that you need to write the return type, because if the information part is float or whatever, it can be anything, depending on what you store in the information part of the node, that should be the return type of the function. Then I'll say int delete del end. So this is the name of the function I'm going to delete in the end. So del end, then I'm opening the function bracket. Int I should be in lowercase because it's a data type and it's a keyword. Function name I started with capital D and then E is also capital. However, it's a user defined function. Whatever you write, the same thing you need to follow. If you give a different function name by calling, it will give you error. Otherwise, the same function name will work. After that, what are the things I need to do? First, I need to declare two pointers of the type node. One is the current pointer, the other one is the previous pointer. And since assuming that I have assumed that there is already an existing list, then I have created head at that time only, or at least the structure of the node is there, and I would have made head is equal to null, or if there are nodes in the list, I would have made head point to the first node. So I don't have to declare head here, I have to declare the current pointer and the previous pointer, prev ptr and current pointer, and int. So before that, sorry, I have to have what are the pointers? They would be pointing to node, so it should be of the type node star current pointer comma star. I will say these are the two pointers which is going to point to the structure node. Then since I am going to have an integer part, like integer in an information part, I will say ELE is a variable which is going to hold the integer part. Then the first thing I need to do is to check for the underflow condition. So I say what are these? These are comments, non-executable lines of code which increases the readability of the source code. And there are two types of comments in C++, single line comments and multiple line comments. Whatever I have written is a single line comment. If head double equal to, why am I using double equal to? Because I have to use a relational operator which states that it will check the LHS with the RHS. If both are true, then it will give me both are same or equal. I can say it will give me a true value, otherwise it will give me a false. And if I should be in lower case, please make that automatically, since it's word, it changes the case of the first letter. But since if or int, all these are keywords, it has to be written in lowercase. Please make sure that you change the case of it. If head is equal to null, if that is true, then what you need to do? Print deletion not possible, list empty, underflow. How do I print it? Cout and deletion not possible, list empty, underflow. Okay, so I'm going to do this. After that, exit. So this is my if. If head is equal to null, see out, deletion not possible, list empty, underflow, and I'm going to exit. If this is not true, that means that I do have nodes to delete, then I need to delete the last one. So initialize the current pointer is equal to head. And now we are going to traverse from the first node to the last node. While current pointer's link is not equal to null, what am I going to do? Pref ptr is equal to current pointer then current pointer is equal to link of current pointer, right? This is the end of your while, or I can put a bracket here only so that it's easy to know. This is the end of my while. After that, once it goes out of the loop, that is when the current pointer would be pointing to the last node, and when the pref pointer would be pointing to the last but one node, it will go out of the loop because current pointer's link would have become null. So it will stop executing the while loop. So here first I need to store the information part of the node in a variable. I have declared ELE already there. So you just need to store the information. Why current pointers information part? Because that is the node which I am going to delete. So after that, what am I going to make? Make the pref pointers link to null because previous pointer would be pointing to last but one node, and now after deleting the last node, that only becomes the last node, and last node's link part should be pointing to null. Fine. After that, free current pointer. It will just make it like deallocate memory. After that, return ELE to the calling function. So this is your function to delete the last node in the list. Getting it? Yeah, please go through that. Node star ptr start previous pointer, like star ptr and star previous pointer. You're declaring two pointers of the type node. After that, you're traversing that from the first to the last node, and since you have two pointers, you made sure that it should be traversed in such a way that one of the nodes would be pointing to the last but one node, the other would be pointing to the last node. Here you are taking just the information part, you are noting it down in a variable, the information part of the node which has to be deleted. After that, you are free, that you're calling the function free, which will make it, deallocate memory and put it back to the availability list, which can be used by any other element. And then you would have also taken, before that, you would have taken the information part, wrote it to a variable, and then you are setting the last but one link part to null, which would make it as the last node in the list. After that, you're just making the free current pointer will just deallocate memory for that. The number of bytes allocated, that many number of bytes would be put back to the availability list. Please have a look. So we finished the deletion. Now will be again, I'll just take you what is circular linked list and then what is doubly linked list and then what are the advantages and disadvantages of linked list. So this would complete the linked list part of data structures. Then we have left with trees and graphs, which we don't have in detail. Tree is important for 1 markers and 2 markers. So I'll just go through that. What are the definitions you should know about a tree? Basically, what is a binary tree, and then how are the relation? What is the relation? Why is that non-linear data structure? How is the relationship between the elements? And then we can see the different terminologies used in trees and graphs. That would complete our data structures chapter itself, and it is a very important chapter. So circular linked list we did, single linked list we did, wherein how do the last node of the list link part would be pointing to null. But then suppose you want a circular linked list is one wherein the last node, instead of pointing to null, the link part of that would be pointing to the first node in the list. See, here also the traversal will happen in only one direction only. In reverse direction I cannot go because there is only one link part which will point to the next node in the list. The only thing is the last node is connected to the first node. So what happens in a circular linked list? Every node is accessible from a given node. For example, I have to access the previous node from this node. What I can do is I need to traverse in this direction to go to the next and automatically the last node is connected to the first node, so I can go there. That is what it means. In a circular linked list, every node is accessible from a given node. That is, from a given node, nodes can be reached by merely chaining the list. Chaining means connecting to one another. So merely chaining and traversing the list, what you can do is you can access the nodes. Like each node is accessible in a circular linked list. Single circular linked list, even though it is traversal in only one direction, once you complete the entire circle, you can go to the nodes which you want. Whereas in a single non-circular, like there is no circular linked list, the last link part of the last node would be pointing to null, so you cannot go back to the linked list. Here again it is connected to the first node, so you can traverse the list. So concatenation and splitting operations are more efficient in circular linked list, that is single circular linked list. So what is the disadvantage? Every advantage, like if there are advantages, there will be disadvantages also. The main disadvantage of circular linked list is that in processing, it is possible to get into an infinite loop. So if the exit condition is not true, then it can go into a infinite loop. That is one of the disadvantages of circular linked list. Have a look. Next is doubly linked list. See, if I want to traverse in both the directions, then I can have the doubly linked list wherein each node will have three parts. One is the forward pointer, one is the backward pointer, and the other one is the info, wherein the information or the data of the node would be stored. Forward is a pointer which points to the address of the next node in the list, and back is a pointer which points to the previous node in the list. That is, you can see here back, this is back and this is forward. So it is going to the next node, it has information, whereas this has the information of the previous node. So back is a pointer which would contain the information about the previous node, and forward is a pointer which would point to the next node in the list. So you can traverse in both the directions. How do I know the first node? That is, head points to the first node in the list. The last node's forward pointer would be null. Then only it means that there are no more nodes in the list, and that is the last node you are encountered. That is, the forward pointer of the last node would be pointing to null, and here what happens? The backward pointer, the back pointer which points to the previous node. For the first node in the list, for head or the first pointer, whichever, would be pointing to that node, and the back pointer, this is would be pointing to null. Here the forward pointer is pointing to null, and here the back pointer is pointing to null, the first one and the last node. The advantages are, one can traverse in both the directions. Yes, we can traverse in both the directions. Insertions and deletions are easy. Yes, we can delete and insert easily and can be used to represent trees. You can use doubly linked list to represent tree data structure. So now, what are the disadvantages then? Every extra memory is required to store both the pointers, like forward and back are the two pointers which keeps track of the next node and the previous node in the list, and it needs lot of memory. There is like extra memory is required to keep track of that. Then doubly circular linked list is similar, but only thing is the last node's right or the forward pointer is connected to the first node. So this is the only difference between doubly linked list and doubly circular linked list. The last node is connected to the first node. Please have a look. So you can see here doubly circular linked list. Then the applications of linked list. Yes, linked lists are used in a variety of applications. Some of them are, it is used to represent a polynomial. It is used to find the sum of integers, used for representation of queues, stacks in memory, resulting in efficient use of storage and computer time, and it is also used for symbol table constructions. Then OS uses linked lists in many ways. For allocation of space may be managed using doubly linked list of variety of size blocks in memory. So these are the some of the advantages of linked lists, and each advantage will have a disadvantages also. I need you to find out what are the disadvantages of linked list. Here we are coming to the end of the linked list, and then we will be starting with trees. Please go through this again, whatever we did today. Hopefully you have understood today's class. Please note down the homework question. Last, we had done two programs. Hopefully you have done your homework and you have studied and did it on your own rather than mugging it up or just copying it. Write a program to delete an element from an array from a given position. After that, write a program to sort the elements of an array in ascending order using insertion sort. So these are the two programs for your homework, which happens to be your lab manual programs, and definitely they would be asked. Like, you need to know how to do it. I don't want you to mug it up. Write it on your, learn it and write it on your own. So what are the two things? You need to delete an element from an array from a given position, and the other one is sort the array. That is, sorting is nothing but arranging the elements either in ascending or descending order, any order you can decide. Write a program to sort the elements of an array in ascending order using insertion sort. So please go through this, write it down. So tomorrow's class we would be completing linked list, and we'll be starting, if possible I will complete even the trees and graphs also. We can start with practical programs of C++ from Wednesday. So take care, stay safe, see you tomorrow. Bye bye.